So before I go into my plans for today, I think it is necessary for me to allow us know why we are even here. Why are we even doing this course? Okay, so it's necessary for the modern day engineer to have some computing skills. Okay, because you will be faced with solving different kinds of problems. Already, for you to solve the problems, you need some understanding of some problem solving techniques. For example, you have to define the problem. When you define the problem, you need to analyze the problem. So when you analyze the problem and you have a grasp of what the problem is about, the next thing is that you begin to develop solutions. What are the probable solutions to this problem? So from the different alternatives, you choose one. Having chosen one, then you implement. When you implement, then you evaluate that, okay, this solution that I've chosen, is it actually solving the problem? So you need to evaluate the results of the solutions that you have implemented. Now, when you define your problem, if you have a clearly defined problem, for you to find solutions, there are several steps, and I believe you are already conversant to some extent with some of these steps. Number one, you actually want to be sure you understood what the problem is, right? Okay, let's say, for example, the typical class problems that you are being given, okay, is the knowledge that you have here that you transfer to real life problems. So for typical exam problems or class problems, you have read through the questions, you have understood what the problem is actually saying. Then the next thing is that all of those words that are inside, some like volume, some like mass, you begin to translate them into symbols. You know that typically you use capital letter B for volume, you use small letter M for your masses. Okay, so you translate the words into symbols. Then you want to represent it graphically, pictorially, so that you know what is actually happening in that problem, that system. You want to know what is coming in and what is going out. In doing that, in representing graphically, all the information that you are given, the known variables that you have values for, you want to put them in appropriate places in your diagram or close to them. Then you want to look out for some words that can give you more information about the problem. For example, if they say steady state, you know what that means. What does that mean? Steady state, you did CHE, what was it called? Is it 221 for you guys? You know what steady state is? I want to assume. Something like that, okay. Then, if they say something like isothermal, you know that they are telling you that, okay, so we want to look for all those keywords that can give you more information in solving the problem. Then, having listed or positioned the known variables, then you want to see what are your unknown variables. You want to position them appropriately in your sketch that is guiding your solution. So once you have that, the next thing is that you want to set up equations that may help you to solve the problem. So in setting up the equation that will help you to solve the problem, you need understanding of engineering principles. You want to know what principle is operational in this problem. So it's from the principles that you think is operational that you set up the relevant equations. So once you set that up, the next thing is that you want to use appropriate mathematical techniques to solve the equations that you have set up. The equation is coming from your engineering principles, right? So you have a lot to do, typically, as an engineer. So some of the laws that I think you should be familiar with by now is the law of conservation. You could apply if you have a problem. It could be that law of conservation is applicable to it. For example, that your 211, I think was part of what you should have done, or maybe they moved it forward. But law of conservation, something like mass is not is conserved in your system, okay, and energy is also conserved, sort of, okay. Those are laws that you can use to solve a problem. You can have equilibrium, you can apply equilibrium laws to your process. For example, later you'll be seeing something like chemical equilibrium in some of the courses you'll be doing here. You'll be seeing, maybe in your physics, you have seen something like force equilibrium. Okay, then we have something like flux equilibrium. So those are things you can apply to the problems that you have, depending on the scenario that you are given. looked at the problem, you know what actually applies. More than one of these can apply to a problem. You can have reasons to blend several of these laws together. I'm just giving you like 3, just for you to appreciate why we are here. Then sometimes you might need to consider rate phenomena. I know you know about your Ohm's law. Something like when the flow of current, I think, is due to potential difference. Then we have something like your Fourier law that is telling you that if it will flow from one point to another, there must be temperature difference, and it's going to flow from a position of higher temperature to, I think, the lower temperature, right? So it's the temperature difference that is causing the drive of the heat flow. So those are laws. You look at the problem, what is happening here, and what law can I put in place. Then once you set up your equation, you know, then you now apply your mathematical methods. So if you can do that, since you have a whole lot to do, and most of the engineering problems that you face in real life, they are complex, so it will generate complex equations. So you want to make life more bearable for yourself by automating some of these computation. So that's one of the reasons why we are here. Okay. Then it ensures that it limits error in your computation, sort of. Although computation using any software is still garbage in, garbage out, but to an extent, it limits human error that can occur when you are doing your computation. So that's why we want to look at some of the softwares that you can use as an engineer. So this is an example of a problem that you can solve with conservation law. So this is a blending process, and we are being required to find, is this on masses, how much of each solution is to be mixed. So if you are going to solve this problem, now no software is going to do magic for you. You need to understand what the problem is about. So I know that this is a blending process, and if I read it very well, if you read it very well, you understand that it's about mass conservation in this case. Mass conservation. So you can write the equations. For example, on the board you have the component material balance. You might decide to write the total material balance. Did you do something like that in is it 211 or 221?
We did it
In both. Okay, I want to be sure it wasn't moved to your 300 level. Okay. So you want to be able to write the equations, and once you write the equation, then you can now solve using any software of your choice. Now this is a very simplified problem because you just have 2 equations. Even without using calculator, you can solve this. But at least let us use something as a case study for you to appreciate what the course is about. You can get a complex equation. Maybe if you have a 10 by 10 simultaneous equation you want to solve, do you want to begin to solve it manually? So that's an example. Then this is an example of this is also a case study. It's about equilibrium. I know maybe from your 300 level forward you'll be doing something that has to do with this. So this problem has to do with talking about equilibrium constant, then also a little bit of material balance. So it's those 2 equations that you are going to put together to get the solution to this problem. So once you put the equations together correctly, then you can now deploy MATLAB to find the solution to the equation that you have set up. So if there is an error in you putting up the equation, then definitely whatsoever you give MATLAB is going to solve it for you, and you are going to have answer based on that. So that means your engineering knowledge has to be good enough. Then when you are setting up your equation, you have to set it up correctly. Then when you are giving MATLAB your inputs, you still have to be very careful so that the output eventually will be what you want. This is another example on potential drive. So this is applying Fourier law to solve the problem. So it is being passed through walls, something like an oven, sort of. So it's being passed through different layers of walls and all of that. So there are some questions that can be solved. By the time you use the Fourier law correctly, you set it up, you get the equation, then you can use MATLAB to solve the problem. So what am I saying? Here in this class, Some engineering knowledge, of course, but I'm willing to guide you through. Then you'll be using your mathematical skills to interpret whatsoever problem we have. That's one. Then you'll be learning how to use MATLAB. But it's a very interesting course, and I think it's one of the courses that people should have something like 100A. It's very possible because it is hands-on. It is hands-on, and the software that you'll be using for this course, they are quite intuitive. They are user-friendly. So for this course, CHE334, there are two applications that will be introducing you to. The first one is MATLAB, the second one is Excel. So this semester I'll be taking MATLAB. In this class, you need computer as professional because any software that you learn or any programming language that you learn, if you don't practice it, it's as if it's of no use. So the more you practice, the more you gain mastery of it. So what is MATLAB? MATLAB is derived from two words, matrix and laboratory. It was initially developed by Clef Moller, as you have seen on the board. So it means that the way they have developed that software or that programming language is based on matrix. So easily you can do anything that relates to array or matrix with MATLAB. So everything you are doing with MATLAB fundamentally is built on matrices, sort of. So like I have said, this course is just an introduction. In fact, it's not going to be a brief introduction because MATLAB is a very robust software. As you will see, by the time you want to install it, it's a very robust software. So no textbook, no teacher can teach you everything about MATLAB. But once you have been introduced to it, you have an idea of how the language is spoken. Then you can develop more on that. Then it's going to be based, the expertise you are going to develop using MATLAB is going to be based on maybe your interests, maybe perhaps your research interest, or if you are working in an industry, whatever your industry is doing. So you now major on, okay, I think this module is relevant to what I'm doing now. Then you look at how it works. So we are just introducing it to it for you to see that, okay, there's something called MATLAB, and these are some of the possibilities that are there. Then from there you build more capacity. So this is not a comprehensive class. In fact, it's not a comprehensive introduction, but I believe you are going to get something substantial from the class. Okay, so I thought we have internet access here. So that is why I included this part, MATLAB installation and requirements. So credit to the school management and CLR. So there is a licensed copy of MATLAB for everyone to use. I think I called one of the staff there yesterday and she told me that students can also use it. So if you want to get access, to the best of my knowledge, to MATLAB, you can log into the CLR using the address on my screen. Can you see it? Just type clr.convenantuniversity.edu.ng. Okay, so this will just walk you through.